find the data.
Why did you ask for changing the place?
Because he doesn't have the offices.
No.
Yes, let's continue. Yeah, I'm just moving the virtual image to an USB because it takes forever. It will take an hour or something to get it to Dropbox, and then you have to download it. So I have one with enough space. So we'll see if it should be done in 8 minutes or something like that. Then you can have it and install it. So .NET Core is a core. They changed into this idea of a core. So instead of having just one version of .NET, they have two versions. So they have this Windows part and then they have this core. And core is a subset of the Windows version. So on the Windows version, you have the full .NET package that are closely related to the Windows operating system, and then you have this core that is not related to the Windows operating system at all, and can be used and moved to other operating systems. That's the idea. So it have had many names, and you will see a lot of names. But core is the name now. So you have this .NET Framework. .NET Framework is running on primarily on top of the version 4 of ASP.NET is running on top of this one here. That's where you Windows applications, the native applications and stuff will run on that part of .NET. And then you have this .NET Core. And as you can see here, I just found these images from Microsoft somewhere. So they talk about ASP.NET 5. It's renamed to ASP.NET Core now. So we are in the process of moving from one, and the ASP.NET is not in the final version. We're still in the beta or the release candidate version. So we'll be actually working with stuff that are not released yet, and that's of course very dangerous when you have to make the slides and stuff like that, because it can actually change before we get to it. But we'll see. We'll try to solve the problem. So this is the idea. You have something that can run on Windows and is specific. That's the full package, and then you have a smaller package that can run on Mac and Linux also. It can also run on Windows, of course. And yeah, so this is the ASP.NET. So that's the framework for doing web applications. So it's so you can see you have this ASP.NET Core. So that's the one we will be working on. And they have ASP.NET 4.6, and that's some difference between these two. They have changed the way that the ASP is working. So the main parts are the same, but some of the especially how you create your backend is a little bit different. Where you here you have the complete package, so you have all the stuff there. So you have this, you can do anything right out of the box. Over here they have introduced the idea of working with middleware. So instead of having the complete thing, you only have the most. So you start with the simplest stuff, and then you can add middleware on top of that. It's an idea that is used in Node and other languages too. So. Because if you only use a small part of everything, then you have a smaller executable, and it's easier to understand because you can see what's happening. So .NET Core can run on top of the full package .NET package, or you can run on the .NET Core. So we will be working here in this .NET Core 1.0. Okay, so it's 1.0. Yeah, that's nice. I actually think we are on 1.0.1 kind of thing. That's the newest version, but it still changed stuff from one version to another, or from one sub-version to another. So application design, you can work monolithic applications, so that's where you you build everything into one single executable file and then execute that, or you can work with component-based applications. That has been the common way of doing Windows applications, and it's also the common way of doing Linux applications, that you have this dynamic link libraries that you can link into the application to the executable, and it needs to be there for the executable to run, so the executable doesn't have all the features. It's stand on top of the libraries. So this is where you do it in the monolithic style, where you just bang everything into the executable and it can run. That can be fine, because you don't have this dependencies to dynamic libraries that needs to be there. So you can still use libraries here. You can use static libraries. So then you have static libraries. You will put the libraries into the executable, and then it doesn't have these dependencies on the outside. But on the other hand, you have to redo everything if there's any changes to the library or something like that. So this is the standard way of doing .NET applications. So we work with these dynamic link libraries, and we can use them by the application. The nice part is that you can change this one and recompile this one without recompiling this one. So as long as this is fulfilling the same, so as long as you have the same interface, of course, if you change the interface here, then you have to recompile over here. But if you just change the way the internals, and you still have the same interface, then you can change the libraries and build them, and don't have to recompile the executable again.
So they're like class files from Java?
No, Java can't do this.
Yeah. Okay.
No. It's like you can have a library. Yeah, you can have an external library. So it's not class files. So you can have a library, an external library you can download, and you can use that. But it doesn't. It's not completely the same, because you. Yeah. So what's the difference? But yeah, you can. So if you use an external library in Java, you download it, and then you have this lib file or whatever it's called. What is it called in Java? It's so many. It's a long time since I did that. No. The class is the class is it's called jar. That's the name of the jar. And then you can use that. So you can do that in Java as well. So you can change that part. But I'm not sure if you change that part, if you have to recompile your Java application. I'm not sure. But you don't have to do that here. At least that's. So if you change anything over here, so you can recompile part of your application without influence the other parts, even though they are using features from each other. Yeah, so what it works with this idea of an assembly. So we have an assembly that is the executable file, and then you have an assembly that is the dynamic link libraries, and then you can reference these libraries and then use them in your application. So that's the idea. The benefits: team programming. I can do a library, and then you can use it, and another one can use another library, and then we can work as a team, and we can work independently. Just agree on the interface, and then we can start doing the internals, and that's nice. You can work with this multi-language development, because one library can be done in one programming language, another one in another programming language, and then you can just use them all together. You can use the code. So if you put something in the dynamic link library, you don't have to. You can use that in another project if you want. So if you have something that is general, you can just put it in a library, and then you can reuse that. And you have this idea of independent updates. You don't need to update everything if you change the internals of a library. And you have this support for good program design, this NTR design. We'll talk about that later. Yeah, I just jumped between all that one. It's just so you have it on the slide here. So now we bang. That was .NET. And then now we have C#, and I will actually jump even faster on C#, but I will try to. I made some slides on issues that I think is important and is different from what you are used to if you haven't worked with C#. And it's just the basic of the language. So next time we will talk about advanced features. So we'll talk about link and all that stuff, events and the functional lambda part. That'll be next time. But yeah, while talking about next time, I don't know. I have to look back to that. So on Monday, I actually teaching right now another course, a course that's given on in communication, a course between communication and computer science. So I'm giving that course. It's a very intensive course. They have courses Monday, Wednesday, and Friday. So yesterday I was teaching there, and tomorrow I will be teaching there, and Monday I will be teaching there. So on Monday we will reverse the order. So you will start with the exercises in the morning, and then they have the lectures after lunch. Because I'm actually teaching on another course in the morning, so I just come running over here and then do the C# part on Monday afternoon. I don't know if it's in Moodle, but I'll change it if it's not there. So Suman will be here Monday morning. That's some exercises for today to try to get into the language and so on. I will talk about that later. Just so I remember to say that part about switching the order, so you know that. Okay, so there's a naming convention in C#, like I said, in many languages. So, so what is the interesting part? Yeah, it's using a mix of camel case and title case. Do you know what camel case and title case is? Everybody know that? Camel case and title case.
Yeah.
There's two different ways of. So Java is more a camel case language, and the C# is more a title case language. But it's both things are used. So do you know what it is? Anybody know?
Camel case is you start with a capital letter, or if it's a combined name like current layer.
Yeah.
You start maybe with a lowercase, and then the layer starts with an uppercase.
Yeah. So this is camel case.
Yeah.
That's the camel case idea. So whenever you do some combined words, you start with a small letter, and then whenever you add a new word, it will be a capital letter. So that will be the camel. The camel will start down here, and then you go like this. And the title case is when you have a title, it always start with a capital letter. So this is the title case here. So that's the two different ways. But so a language can be more camel case-ish or title case-ish, and C# is title cases. That means that the methods are in title case, while in Java it's in camel case. Do you need to do that? No, not at all. But when you move into a language, it's a good idea to follow the principles, because it makes it much easier for everybody else to look into your code if you're following the standard for that language. So you have that's something you can always take this point of view, say, hey, I want to do it my way. Yeah, but then you can go to that corner and sit there and do whatever you want to do alone. Nobody wants to deal with you, and you will not be part of anything. And I've seen people being at a job interview, and then not me necessarily, but my boss or him and me together, so talking to people, and then one of the features that you want of people that you want to hire into your environment is actually they have to be a team player. That's number one. If they're not a team player, so why hire them? They can be so skilled, but if the only thing they can do is sitting down in the corner and do something for themselves that nobody else understands and nobody else knows how to use, what use is it for the company? Then you need to be a team player. But one part of being a team player is following the naming convention, because it makes it easier for your colleagues to understand what you're doing. That's makes sense. And I think, yeah, I have run into different opinions, people that do stuff in a specific way, and somebody can be completely obsessed about. You need to have the curly brackets like this because otherwise I can't sleep at night. Kind of obsession. I know I've worked together with people like that. That whenever they put a